very convenient numbers of less than 24, where everything was out of 100. And we're going to extend what we know about equivalent ratios and decimals and extend our knowledge of percents. In example 1, Sam says that 50% of the vehicles are cars in this picture. We need to give 3 different reasons or models that prove or disprove Sam's statement. Our model can be tape diagrams or 10 by 10 grids or double number lines or anything that represents visually what we're looking at in the drawings of cars and trucks. There are 3 cars and 2 trucks in our picture. So the total number of vehicles that we have are 5. Knowing that, we could do a rectangle We could draw a rectangle that has 5 parts to it. Then we could shade in the 3 parts that would be cars. I'll shade in pink. And visually, we can see that these 3 pink out of a total of 5 can't possibly be 50%. They are not half of our diagram. They are more than half of our diagram. The fraction of cars would be related to the percent because we can do 3/5. And then if we make an equivalent ratio or an equivalent fraction, we would need to change this to 100ths. And 5 times 20 equals 100. So we would need to multiply our numerator, or the 3, by 20 as well, which would give us 60 out of 100. There's our fraction. Knowing the fraction out of 100 allows us to write 60%. So our fraction is related to the percent because it shows out of 100. The model proves that the fraction and the percent are equivalent because we could even cut down these little pieces further. Example 2 says a survey was taken that asked participants whether or not they were happy with their job. An overall score was given, and 300 of the participants were unhappy, while 700 of the participants were happy with their job. We need to give a part-to-whole ratio for comparing happy participants to the whole, and then write a part-to-whole ratio for the unhappy participants. Our happy participants were 700, out of a total of 1,000. We know that it's a total of 1,000 because we add 300 and 700 to get the total. As a percent, we would need to simplify this ratio to make it out of 100. And we could take 1 0 off of both of these to get to 100. That would be the same as dividing by 10. If we divide by 10, 700 divided by 10 would be 70, and 1,000 divided by 10 would be 100. And from this fraction, we can clearly see the percent is 70%. Likewise, our unhappy Participants would be 300 to 1,000. Remember, part to whole. And if we do the same thing to those numbers, we'll find that 300 divided by 10 would be 30, and 1,000 divided by 10 would be 100. And so our percent would be 30%. Moving on to exercise 1. Renita claims that a score of 80% is the same as the fraction 4/5. She drew this picture in order to support her claim. We need to tell whether she is correct and why or why not. In looking at this drawing, we find that there are 5 rows and 20 columns. It's a 5 by 20 diagram. 5 times 20 is 100, so there are 100 pieces here. Out of those 100 pieces, she has shaded 4 rows of 20, which is 80%. But interestingly enough, because she didn't draw a 10 by 10 grid, she drew a 5 by 20 grid, we can see that 4 out of the 5 rows have been shaded. 4 out of 5. So she seems to have correctly represented it in showing these 4 rows of 20. We could change her picture one last time to make it easier to see why she's correct or incorrect by taking out the vertical lines. If we just had the horizontal lines, we would still have 4 out of 5, but we wouldn't have all of these little divisions across the top. Exercise 2 is showing a tape diagram, and our tape diagram is marked off both in fractions and in percents, very much like a double number line. 80% is what fraction of the whole quantity? We go across, find 80%, and there's 4/5 above it. 1/5 is what percent of the whole quantity? We go across on the top of the tape diagram, find 1/5, and drop down to the percentage, which is 20%. 50% is what fraction of the whole quantity? Go across on the bottom of our number line, and 50% would be right here. But 50% is a very commonplace percentage. So we should know that 50% is 1/2. And finally, 1 is what percent of the whole quantity? 1. Hopefully we know this without having to look at the diagram, but 1 is 100%. Exercise 3. Maria completed 3/4 of her workday. You need to create a model that represents what percent of the workday Maria has worked. In order to do this, the 3/4 could be 3 pieces out of 4, but that won't translate to a percent. So what we really need to do is to have a chart that will show us how many pieces would be in each of those fourths. And I won't complete the whole thing for you, but I would suggest that if we start off very similar to what we had before, in which we have 4 vertical rows, And then in order to make this truly represent 100, each of these four would need to have 25 pieces in it, because 100 divided by 4 is 25. So we would need 25 pieces in each row. Then when we shade 3 out of the 4, we ought to find 25 in row 1, 25 in row 2, 25 in row 3, and 25 plus 25 plus 25 is 75%. We'll jot that down here. So 75% of her workday has been completed. What percent of her workday does she have left? Well, we find that out by subtracting from 100%, because it is the whole. And 100 minus 75 is 25% of her workday, which is left. Your model proves that your answer is correct, because there would be one piece left that was not shaded, and that one piece should have 25 sections in it after you divided yours up. In exercise 4, Matthew completed 5/8 of his workday. What decimal would also describe the portion of the workday he has finished? We would need to take 5 and divide it by 8. So the 8 goes outside, and our 5 would go inside. And we know right away that 8 does not go into 5. So we'll need to add a decimal point and a 0 to start our division. When you are dividing decimals, you need to put the decimal point directly above where it is in your dividend. That's the number you're dividing. Since we know 8 does not go into 5, we would put a 0 in front of the decimal point. And then we need to know how many times 8 goes into 50. And since 6 times 8 is 48, we can say that 8 goes into 50 6 times, which is 48. We would subtract 48 from 50, which is 2. Since we still have a remainder, we need to add another 0 and bring that 0 down. 8 goes into 20 2 times, which is 16. And we'll need to subtract 16 from 20, which will give us 4. And again, we still have leftover, so we need to add another 0 and bring that 0 down. And 8 goes into 40 5 times. So our decimal, the decimal that describes the portion of the workday that he has finished, would be 0 and 625 1/1000ths. We can use that decimal to get the percent of the workday by doing a little shortcut. Since we know that percents are out of 100, we can move the decimal point on any number 2 places to the right. Since 100ths are 2 places to the right, we would move that 2 places to the right. And then rewrite the number as 62.5%. In exercise 5, we're going to write fraction, decimal, and percent equivalents. Remember, if you have a fraction, you should divide the numerator by the denominator, and that will give you the decimal. And then from the decimal, we can write a percent by moving our decimal point 2 places to the right. So 3/8 as a decimal is 0 and 125 thousandths. And when we move the decimal point 2 places to the right, that would give us 12.5%. In the second row, if our decimal is 35 100ths, we can move the decimal point 2 places to the right, which would give us 35%. And as a fraction, we can write 35 out of 100. But now we should simplify that. And since both 35 and 100 are divisible by 5, if we divide 35 by 5, we get 7. And 100 divided by 5 is 20. So our simplified fraction would be 7/20. In the third row, we have a percent of 84.5%. If we want to work backwards, which is the only way we can do right now, we would need to move our decimal point back to the left 2 places, which would give us a decimal of 0 and 845 thousandths. Notice all I did was move the decimal point back to the left 2 places. And our fraction would be 845 1,000ths, which we can then simplify or we can leave it the way it is for now. The next example, 325 1,000ths. If we move the decimal point 2 places to the right for our percent, we would end up with 32.5%. And simply reading the decimal 325 1,000ths allows us to write the fraction 325 1,000ths. Finally, 2/25ths as a fraction. We need this fraction to be 100ths. So we can divide 2 by 25. And we could also make an equivalent ratio with 100 in the denominator. Either way, we're going to find as a decimal it is 8 100ths. And then following the same rule of moving our decimal point 2 places to the right, we would get 8%. The last exercise in lesson 25 is for you to choose one of the rows from the conversion table above and use models to prove your answers. Those models can be a 10 by 10 grid, a tape diagram, a double number line, anything that we have used before that makes sense for you to represent these numbers.